Welcome to 4-1 Notes with Mr. Joyner. We're going to start a chapter on numeration, number representation. So at the top of your notes, we're going to start with 4-1, and guess what? I'm splitting these up into parts as well. This is going to be part 1. And for whatever reason, I like using Roman numerals for the parts. All right, we're going to call this chapter number representation. Yeah, that's how you spell that. It took me a second. Okay. And then today's lesson is on the Hindu-Arabic positional system. And you're probably wondering, why are we learning about Hindu-Arabic numerals? We have our own number system. Well, lucky for you, this is our number system. We can just call it the Hindu-Arabic positional system or number system. Hindu-Arabic numerals. Okay, that's gonna be a Y there. Okay, having some issues with the writing here. All right. So the Hindu-Arabic numerals. Let's see. This is a fancy name for our numbers. All right. Just a fancy name for our number system. So you're going to see this name, you're going to see Hindu-Arabic come up a lot in this chapter, and hopefully after today you don't have any issues with it, because let's just look at some examples of some of these numerals. That one looks familiar. You might have seen, oh geez, you might have seen that one. So obviously, when a long time ago, they're trading goods. They're floating on ships, trading goods at different places, and this system won out. This one was just more convenient than Roman numerals. A lot faster to work with. Basically, it's a positional system. Here's some other number systems that we could compare it to. So we have the tally method. So if we did a number like 16 with tallies, now this is going way back. This is going way back to where the very roots of counting would be like tally methods. In fact, they've found counting on bones. You could look it up. They would use old animal bones and do tick marks on the bone to count. Then we had Roman numerals, a little more developed, just not very convenient. So 16 in Roman numerals, if you're not familiar, we'll do this in another section as well. X is 10, V is 5, and I is 1. So that would be 16. That's supposed to be an I. Okay, anyways. And then Hindu-Arabic. Let's see how elaborate this one is. How would I write 16 in Hindu-Arabic? Oh yeah, you write it like 16. And you can already see, just comparing these three systems, this one seems pretty easy to work with. Let's see. So let's see if I can write a paragraph without taking forever with this pen and stylus. Okay, so it's called a positional system. Because the placement of a number changes the place value. The placement of a number changes the place value. the 1 in 16 represents the tens place. Okay, so that should be a review. But we're going to be, this chapter, we're going to be comparing different number systems. The fun ones will be the ones from, Egypt, Babylon. We'll do some old ones, and you're going to be like, well, why are we learning these? But then we're going to do some newer ones, like binary. That's using technology. Okay, so let's do, to get good at these number systems, we have to do some exponents practice. Okay, let me work. I think I got to slow down on this writing. Here we go. See if I can get a word written down. Exponents practice. Let's start with um, 10 squared, 10 to the second power. And so just to review, exponent, that means you're going to write it twice and multiply them. 10 times 10 is 100. Okay, 10 to the third power. Now we're going to write it 3 times, multiplying them all. That would be 1,000. Now the shortcut with tens, which is really nice, is that's 2 zeros, 1 0 0. 10 to the third is 3 zeros, so 1 0 0 0. So let's make a wild guess at 10 to the 4. 10 times 10 times 10 times 10, and you guessed it, there's going to be 4 zeros. That'd be 10,000. Okay, what about 2 to the 6? Not quite as convenient. But we are going to write this 6 times and multiply them all the way down. All right, so that is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. How about 1 to the 7? This always gets some people who haven't been doing exponents for a little bit of time. That'd be 1 times 1 times 1 times 1 times 1. That is 1. Okay, what if I did 7 to the 1? Let's write 7 one time, and you don't really need to multiply anything. Okay, so we're going to be doing a lot of exponents for some of these sections. Let's do the expanded form of Hindu Arabic. All right, expanded form. So I'm going to take a number you might have seen before in your lifetime, 673, and we're going to expand that. The first step to expanding it is just separating it. That's 6 is in the hundredths place, plus 7 in the tens place, plus 3 in the ones place. And we're not done expanding. When you get to Math Excel, they're going to want a couple more steps before you write your answer. That is 6 times 100 plus 7 times 10 plus 3 times 1. And Math Excel still doesn't want that as your answer because they want 10 squared for that one. They want 10 to the first power here. And then 3 times 1 is good. Okay, this might look like scientific notation right here. But this would be your final answer right there. Let's try, on my notes I had to go to the second page, but I'm just going to keep on rolling down here. Let's do a 3,417. So 3,410, yeah, 10 plus 7. So that would be a 3 times 1,000, 4 times 100, 10. That'd be 1 times 10. And 7 times 1. And I forgot that in my last example, I put these in parentheses. There we go. The parentheses are actually not necessary. They just group them so it's visually easier to understand. I have not tried on Math Excel to write this without the parentheses, but if you want to give that a go, go ahead. That's 3 times 10 to the third plus 4 times 10 squared plus 1 times 10 to the 1, pretty sure you need the 1 when you're putting in your answer, plus 7 times 1. That is the expanded form of 3,417. All right, let's go crazy. We got four more examples. Let's go 53,025. So I added a little trick in here. I don't know if you see it. Okay, so we've got 50,000 plus 3,000 plus, well, there's nothing there in the hundredths spot. Let's just put a 0, but we're gonna cancel that out. We're not gonna write it on the next step. Okay, so that's gone. Let's see if you can follow me along if I just go straight to the last step of writing 5 times 10 to the 1, 2, 3, 4 plus 3 times 10 to the 1, 2, 3. Leave that one out. 2 times 10 to the 1, 0 plus 5 times 1. Okay, let's go ahead and let's go backwards now and see if you can follow along. Most of the math is just a puzzle, so I'm just going to add some puzzles in here and see if you can work through it. Here's your first one. 7 times 10 squared plus 5 times 10 plus 4 times 1. Now what number could that be? Now as long as you've got all the 10s in order, 2, 1, 0, then we can just write these numbers. That's 754. And that's how you go backwards with the expanded form. I guess you'd be condensing it. Let's try another one. Obviously I'm going to try to make it a little bit harder. Right, 6 times 10 to the third plus 7 times 10 to the 1 plus 3 times 1. Now for those savvy listeners, you're going to see exactly what I did. I skipped the 10 squared, the hundredths place. So you can't just skip it in your answer. You have to use a 0. Okay? So 6 for the thousands place. Put a 0 for the hundredths. 7 for the tens. And 3 for the ones place. Okay? Let's just add a note so when you look back on your notes, you know exactly what we did. Use a 0 for missing place values. Okay, so let's go crazy on this last example and see if you've been paying attention. 8 times 10 to the 5th power plus 9 times 10 to the 2nd power equals, what is it, 89? Is that our answer? 89? Of course not. We are missing. We got to list all the ones we're missing. We're going to have to add zeros. We're missing 10 to the 4th, 10 to the 3rd, 10 to the 1, and 1. Okay, that's all. So we need 4 zeros in there. We're at 8. We're missing these two, so use zeros there. We've got the 9 in the hundredths spot. That's it. And we've got a 0, 0. All right. Good luck on the Math Excel. Please ask questions.